Hello and welcome back to SQA Higher Maths, Applying Differential Calculus, the optimization topic. So in the previous video, we showed that the area of this triangle is given by a half p cubed minus 6b squared plus 45 over 2p. Okay, so go back and have a look at that if you need to. Part B, find the greatest possible value of A and the corresponding value of P for which it occurs. Okay, so that is basically just going to be a maximum minimum turning point question, but we also need to consider the end points. We need to consider 0 and 7 as well. Okay, so we could have a maximum value and at the end point it might be higher than that maximum value. Okay, so the greatest value occurs either at a stationary point or at an end point. So we need to differentiate. So it's a reasonably straightforward one to differentiate. It's just a cubic. So we'd end up with 3 over 2p squared minus 12p plus 45 over 2. Make our statement. So we've got all of this equals 0. So I'm looking at that thinking, well, I don't like factorizing with fractions. So I'm going to take out 1/2 as a common factor. So in the bracket, that leaves 3p squared minus 24p plus 45. So again, I'm looking at that thinking 24 and 45 are quite large numbers. 45's got enough factors to make it annoying if there's a 3p squared at the front. However, I am thinking they're all in the 3 times table, so I can also take out a common factor of 3, which leaves 3 over 2 p squared minus 8p plus 15. So guys, if you're ever doing a question, if it's got fractions in it, take out the half as a common factor, and always look for a common factor before factorizing. Makes your life so much easier. So factorize this should be straightforward for you guys. P minus 3, p minus 5. So our two values of p will be 3 and 5. So we need to look at which one's a maximum, which one's a minimum. But hopefully by this point, you are all thinking, where is it? It's a positive cubic, so it should come up, flatten out, go down, flatten out, and go back up. So we should get a maximum turning point, then a minimum turning point, and then the curve increases again. Remember, if it's a negative cubic, it would come down, go up, and go back down. So I know just by looking at that, I should be getting maximum, then a minimum. Okay, so let's go and look at the nature table. So let's look just before and after 3 and just before and after 5. It says DADP in factorized form. So if we substitute 2 in, 2 minus 3, 2 minus 5, they're both negative, multiply them together and also multiply by 3 over 2, we'll get a positive answer. Substitute 3 in, the first bracket will be 0. Remember, we've got to pick a value between 3 and 5 if we're looking at the points. So 4 is really nice to pick. 4 minus 3 is positive, 4 minus 5 is negative, so we're going to get a negative slope here, which will also be the same as this part. Substitute 5 in, we get a gradient of 0. Substitute in 6, 6 minus 3 and 6 minus 5 are both positive. Multiply them together, so we're going to get a positive gradient there. So we've got a maximum turning point at 3 and a minimum turning point at 5. Remember, evaluate the endpoints, because we're not asked for the maximum turning point, we're asked for the maximum value. So what's the value of p when p is 0 and 7? Also evaluate when p is 3, because we know that's a maximum. We don't need to evaluate when p is 5, because we're not interested in the minimum. So when p0 is 0, if we think about it, we know that's going to be below, because we know it's going to increase to a maximum, then a minimum, and then increase again. So it's really only this one we're concerned about. So substitute in 7, and we get a value of 35. So that is going to be a higher value there. Okay, when P7 is 35, so the greatest possible of A, the greatest possible value of A equals 35 square units, and that occurs when P equals 7. Okay, so once you've done part A, again, part B is basically just a closed interval question, which is a stationary point plus look at the value at both ends. Okay, guys, so you really need to know how to do your stationary point questions.